In this video, we will learn about identification of gases. So the first gas is hydrogen and it is written as H2. Hydrogen gas can be produced with the help of active metals. Active metals are actually the metals which have very high reactivity. So whenever active metals like zinc react with dilute sulfuric acid or dilute hydrochloric acid, they produce hydrogen gas. Here you can see that this upward arrow shows that hydrogen during this reaction is produced in the form of a gas. It can also be produced with the help of zinc, aluminium, tin, and lead whenever these metals react with hot and concentrated sodium hydroxide or potassium hydroxide, they result in the formation of hydrogen gas. The points of identification of hydrogen are: number one, hydrogen is actually a colorless and odorless gas. It do not show any color change in litmus. That means it is actually a neutral gas. The third and the most important point is that whenever during a chemical reaction hydrogen gas will be produced, you will always hear a pop sound. It is very important to remember that hydrogen gas always produce a pop sound. However, hydrogen gas is not a promoter of fire, but whenever it is burnt, it always burns as a pale blue flame. The next gas that we will study is oxygen, and it is denoted as O2. Oxygen can be produced on heating potassium chlorate and hydrogen peroxide. So with the help of the given reaction, you can see that potassium chlorate and hydrogen peroxide on heating give oxygen. There are other examples also which on heating produce oxygen, and these are potassium dichromate, potassium permanganate, and lead dioxide. The second method for the production of oxygen is by heating metal nitrate. Here you can see that sodium nitrate is taken, and on heating we are getting oxygen. Now, for oxygen, the points of identification are that it is a colorless and odorless gas. The second point is that it does not show any change in the color of litmus, which concludes that oxygen is also a neutral gas. Oxygen is actually a promoter of fire. So whenever glowing splinter will come in contact or closer to oxygen, you will always see that it glows more. When we talk about alkaline pyroglycol solution, it is colorless. But if oxygen is passed through the solution, you will see that the solution turns brown. The third one is water vapor. So water vapor can be obtained by heating hydrated salts. Now hydrated salts are the salts which have H2O molecule combined to them. Here you can see that 10 H2O molecules are already present. So on heating such salts, we get water vapor. Points of identification of water vapor are that it is colorless and odorless gas. Whenever anhydrous copper sulfate, initially you can see that H2O molecules are not combined with copper sulfate, but once it becomes hydrated, the color will change to blue. The fourth gas is carbon dioxide, and it is written as CO2. So when we heat metal carbonate, here you can see that we have taken metal carbonate and We can also take hydrogen carbonates whenever metal carbonate or hydrogen carbonates are heated with dilute sulfuric acid or dilute hydrochloric acid, we get carbon dioxide. Again, this upward arrow shows that carbon dioxide is obtained in the form of a gas. Points of identification are that carbon dioxide is a colorless and odorless gas. It turns blue litmus to red. That means it is showing a color change in the litmus, and it concludes that it is of acidic nature. So carbon dioxide is actually acidic. Burning wood splinters gets extinguished, which means that carbon dioxide is not a promoter of fire. It will never promote fire. That is the reason we use carbon dioxide in the fire extinguishers. It always turns lime water milky. Whenever it is passed through lime water, you will find a precipitate. This precipitate is insoluble calcium carbonate. This is an insoluble precipitate and hence it turns lime water milky. The fifth gas is sulfur dioxide. It is written as SO2. Sulfur dioxides are also obtained by the action of dilute sulfuric acid. Here you can see that dilute sulfuric acid is showing reaction with metal sulfite or bisulfite. So when metal sulfite or bisulfite react with dilute sulfuric acid, they result in the formation of sulfur dioxide. The second method is we can simply burn sulfur in the air. This is the simplest example of production of sulfur. So sulfur plus oxygen will produce SO2. The third method is by boiling copper turnings. So copper turnings on boiling with concentrated H2SO4 results in the production of sulfur dioxide. Points of identification of sulfur dioxide are it has a very suffocating smell. Here you can see that SO2 in large amount is evolved, and since it has a very suffocating smell, it is very hazardous to health. The second point is it turns litmus to red. That is, it turns blue litmus to red, which shows its acidic behavior. Therefore, we can conclude that sulfur dioxide is acidic. The third point is that potassium dichromate. We can see that potassium dichromate is initially in orange color, and when we acidify it with H2SO4 and then pass sulfur dioxide, it turns green and it also decolorizes. We know that potassium permanganate is actually in pink color. So on passing SO2 through potassium permanganate, we can see that it actually decolorizes. I hope this topic is clear to you. Thank you.